So guys, next up, I'm going to show you sort of another way of doing something very similar to that. But what I think we probably want to focus on more than anything else is the idea of geometry, right? So like, how are we utilizing geometry to develop our design, right? Our approach so far has been to basically take a particular profile, pull it to a new location, and then loft it together, right? And then we created these very tight, very compact transitions in order to get us to where we needed to go. So using the revolve feature can be huge for that, like massively huge for what it is you're trying to do. The downside is doing the actual transition like this right here becomes a little bit more difficult when you're using the revolve as your primary design tool, because you can only do a revolve in one axis or around one axis, right? So you can't do a revolve and scale. So that's where supplementing it with alternate geometry comes into play. How many of you know what I mean by that? Not very many. Okay. All right. So what I mean by that is essentially this, right? If I have, where's that profile curve? There we go. Let's make another one. All right. So if I have this curve, I can basically copy this curve or extrude it back to, say halfway back, right? Not a problem. And when I look at it from the side view, which is going to be helpful for us, that curve is right there. So that's halfway back across that surface. Let me move this. Actually, I have to go back to, yeah, there we go. That's what I want, this one. And move that. There. Okay. Did that draw it? No, it didn't. Hang on, guys. I just need to get the geometry I need. This guy. There to there. Curve. All right, cool. Good to go. All right. So if I copy this thing back halfway, it sits here, and if this is what I'm trying to build, right, on the back side, I have some options. I can basically just take my geometry and revolve this thing into that position. And using the revolve, it's going to create, whatever other geometry I need. And then I can use other subtractive geometry to sort of sculpt it into what it is I was trying to create. And I'm going to probably not do this perfectly on a few instances, but let me copy from the top here. Let's see, I'm going to copy from this corner because it's the flat corner. There to there. And then rotate this into place. Okay. So what I need to be aware of here is that revolve is a radial function, so the distance from here to here needs to match the distance from there to there. Okay. If I already have the geometry, I'm sort of cheating with this. I sort of already have the geometry, but that's where I need it to be, and so I need the I need this to be the same distance away. So I could either measure it, or I could copy it, or whatever it is I need to do. Tell you what, let's just do this. Get rid of that. Get rid of that. We're going to work this way. So revolve is going to be sort of heavily geometry dependent, so I would usually use like a secondary layer to draw out what it is I'm doing. So with a line, actually with project on and a line, I'm going to go straight up here, and I'm going to actually pick what radius I'm going to use, right? So you guys as designers, you're going to develop actual geometrical, overlays or underlays, whatever you want to call it, a geometrical structure to what it is you're designing. So you need to have some kind of variable in mind. In this case, I'm going to do a line back down of, I don't know, what scale am I at here? 50 feet. And then put it there. I'll get rid of that original line. Okay, this one is going to be placed on the top of that element, and then that is going to be my center point. I don't have to leave that geometry there, it's just the way I chose to do it. There are a million different ways of creating construction geometry. But this, right here, this curve, is going to be revolved. Whoops, revolve, select curve, that, revolve axis. Oh, I need a secondary axis for this one. Hang on. I need to draw another line. There to there. That wasn't as easy as I thought. Move. There. To there. Project back on. Okay, now I've got my axis. So I'm going to revolve this thing, and I'm going to select this curve. Then I'm going to go from that point to that point for my revolution axis. And so now I'm actually going to be moving this thing to wherever it needs to go. If it's going to be 45 degrees, it's going to be a really sort of wide transition up to that point. I'll do 45 for now and leave it heavily exaggerated. Oh, whoops, sorry, that was the start. My bad. Let's do that again. Curve to revolve is that. Enter my center axis is that, and I'm going to start here and then go 45 up. Okay, so like I said, the downside is that actual volume can't really truncate the way that I was operating with it before. Okay, so we as designers need to figure out where is it going to truncate, or how am I going to generate the geometry that's going to truncate it from the side. So I'm going to quickly just do sort of a secondary exercise with this, and I'm just going to draw another profile curve around the outside. And I'm going to want to revolve it. Yeah, okay. I want this to be the... I'm just trying to think of how I want to describe this here. So this is the right-hand side, so left-hand side. Yeah. So this one I'm actually going to, do I want to do it there? Nah, don't worry about it. I'll just do this. I'll draw another line with project on from here, and then follow that out 50 feet. Okay, so this is going to give me my tangent curve to go back up the other way. And with that, I'm going to select these curves. Oh, you know what? I need another one of those thingies. Wait. Yeah. So copy the rotator from there to there. Okay. And I'm going to grab these curves. Sorry, that guy, and I'm going to now revolve that across this axis from here to another 45 degrees. Whoops, I went the wrong way. Revolve, start of axis, end of axis, start of revolve here, and I could just hold shift should give me a 45 option. Alright, I'll just type in negative 45 because it's not behaving and it wants to go the opposite direction, but negative 45 will put me back up there. Okay. This right now, I mean, it feels like a lot. I explained a lot, I kind of drew a bunch of lines, but now if I wanted to replicate exactly that geometry, I could replicate exactly that geometry in a very, very controlled way. Okay, so after that point, I'm going to join these two. And, for all intents and purposes, if I want to do a subtractive exercise, I need to actually get this geometry to act like it's a solid. Remember, Rhino doesn't actually model solids, it just creates surface-based polysurfaces that act like solids. So I can cap this, and it creates kind of a solid sort of condition here. And so now I have the ability to create a secondary geometry that's going to truncate it for me. So I'll just do one like this, and I'm throwing one out there at sort of a random axial value, but I'm just going to do a big box sort of off to the side of it, something like that. I'm going to move it into place. I'm going to rotate it so that it cuts a little bit of it off, and then I'm going to use a Boolean subtract. So move this guy. Project is on from here to there. Then I'm going to rotate this from here down to the midpoint there, right? And then I'm going to Boolean difference. And I'm going to select the surface to subtract from, that's this, and the one to subtract with, that's that, and it cuts it off. Okay, so this sort of, in terms of like design exercise and what it actually is attempting to do, this provided a great degree of control, but it's sort of accomplished the same thing, right? Essentially, the front side of the building, and if we wanted to loft these two together, we could, right? To create that little portal or entry threshold or whatever you want to call it. But then it's going to sort of, tick off and then go off to this side right there. So you probably will have sort of a doozy blending those two together if you needed to blend them together. Or what you could do otherwise is actually create a tangent line that goes, a profile curve and just kind of pull it up. I'll talk to you about that in a little bit. But anyway, the reason I wanted to show you this as another alternative is that rather than having to go through with your flat surfaces that you rotated, or that you're filleting, you could also create positive geometry, subtract negative geometry, and then use your fillet functions. So fillet surface will also work on this rather complex curve, there to there, and, oh, it didn't join those surfaces together very well, huh? Hang on, let me try if I Boolean union. No, it didn't let me do it. Merge all faces, maybe that'll help me. Didn't really. Doesn't like those two. Well, let's do fillet surface. Go from there to there. Another one from here to here. And we should be able to trim those two off from each other. Actually, yeah. Well, let's give it a shot with trimming it. So I'm going to trim with this guy. And this, trim that off, trim that off, doesn't like trimming that one, let's trim that, whoops. Hang on, I'm going to explode this, get rid of that, and that. And let's trim. Trim with this. Let's get rid of this. If it lets me, it won't let me. All right, hang on. What is it doing? Well, something's going on here. All right, so I'm going to do it this way then. Since they're not behaving, I am going to take this and split it, planar surface, and I'm actually going to split the geometry. I'm going to split this using this. Okay, so without that, now I have a separate set of surfaces here and a separate set of surfaces there. So when I do that, that fillet, it should actually stop at that surface, which will allow me some flexibility to blend the two of them together, if you follow my intent. So I'm actually going to just explode all of these and then get rid of this and that. And let's do fillet surface from here to here, from there to there. That's a little cleaner. Can I see the difference? Ah. It's very, very hard to see what's going wrong here. I'm actually not quite sure, but I can see a double line. So maybe they're overlapping a little bit and not quite tangent. Let's see, can I join them? And merge all faces. Didn't let me merge the faces, but I could join them. Ah, you guys seeing what I'm seeing here? A little bit of an issue there. Well, all right, I'll have to think about how to clean that part up, but maybe it's just not really tangent on this surface. Okay, well, anyway, the other thing that I wanted to quickly show you before I release you to do a little bit more exercises on your own is back to this thing right here. So the last thing that I wanted to get to you is that at the same time you can prepare a geometry that is secondary to this just by using curves. So let's go back into wireframe, and I'm actually going to go into the top view for this one. So I have a curve, or like an extension geometry right here. I'm going to use that to generate my interp curve, which is going to create a positive geometry that should be relatively tangent to the surface. So here and interp curve there. Let's do, not a handle curve. Let's do it this way. Let's do it with a polyline, actually. Can I do that with a polyline? Yeah, I can. Polyline, and I'm going to use it with project on. So I'm actually just going to click here to here, and then type in A, and it switches it to a tangent curve. So then from there, I can actually go back to, say, you can actually draw the geometry to get exactly the midline or the quarter line or something like that, but I'm just going to guesstimate for now, and then I'm going to come back up to the midpoint there. So what does that do? That allows me to actually create, let's do this, I'm going to Alt-click Shift there, a geometry there, and use that to extrude why won't it let me extrude? What is it doing?
Can you do like offset surface?
I could. Why won't this let me extrude? Oh, because it's well, no, it should still. Oh, because it's all right. Let's do a. That's right, because they're two separate surfaces. So I'm going to explode them. They're all three surfaces. Yeah, offset surface is probably better. That's a good creative one. Huh?
Could you split from there as well? This is going all the way through.
Yeah, actually, you're right. Split would work too. Split is the path of least resistance. So, so split, and we'll select this. Man, you guys are on point today. Hit enter, and then cutting object of that extrusion. Yeah. Whoops. So we can get rid of that, and then we're left with that. You would have to, I forgot that, you would have to, I was trying to make a positive geometry to use Boolean. If you use split, it's actually going to remove, it's not going to fill in the gap there. So theoretically, you could split it, and then trim, and then you use the actual geometry as a cutting object, and then get rid of everything around it, like that. And I just make this proper layer, and then rejoin and do all that. Okay, so I'm trying to give you alternatives for what it is you're going to be doing going forward. And then, so what I'd like you to do here, it's getting close to about 8 o'clock. I would like you to have sort of like 3 different ways of creating that transition. I want you to explore it in a few different ways. So you can use lofts, you can use sweeps, or you can create an interp curve and extrude a long curve. or something like that, but just try to make it smooth and controlled. So, and I suggest using some geometrical construction lines. Are there any questions? I'm going to give you guys probably about like 20 minutes to mess around with that before we actually move into more of an assignment kind of thing.